Angles in trigonometry are often made by having two lines on the coordinate plane, usually taking off from the origin. And so in the example that we see here, we have exactly that. So we have an initial side, which is along the positive x-axis, and that is usually going to be the case. So there's our initial side. And then we're going to rotate either counterclockwise, which is the positive direction, or clockwise, defined as being the negative direction, to a terminal side. And so that's the side that we see here. The one that we're rotating to is the terminal side, because that's where we're ending up. That's where our angle terminates. Now we have two angles in this picture. One, alpha, is going to have a positive measurement because we're rotating in the counterclockwise direction. And the reason we term that as being positive is because that takes us through the first quadrant to get going, where both the x and y coordinates are going to be positive. So we've got an angle alpha, which is starting from this initial side and ending up at this terminal side, rotating counterclockwise. But then we also have this angle beta that is starting and ending in the same place, just getting there by rotating in the opposite direction, in the negative direction. So we would say that the angle has a negative measure, as we'll see in just a moment. But these are called coterminal angles because they have the same initial side and they have the same terminal side. So angles that have those two features that are the same, but they'll have different measurements, are called coterminal angles. So if we look at the examples below, we have the same two blue lines in all three diagrams. And so in our first diagram, we've got the measure of that angle is indicated to be 65 degrees. So rotating from the positive x-axis up to this terminal side is 65 degrees. So in the second picture here, we're rotating an extra full revolution. Now remember, that's 360 degrees. A full circle is 360 degrees. And then we still have this piece here, which we established at the beginning is 65 degrees. So to figure out what the measure of this angle that's indicated in the diagram, so if we erase here a little bit so we can see it again. So with this full extra loop in there, we're going to add this extra 360 degrees to the original 365, and so we get an answer of 425 degrees. So this 425 degree angle is coterminal with this original 65 degrees. It's just we have an extra revolution in between our start at the initial side and our finish at the terminal side. And then in the third example here, we can see that we're rotating in the opposite direction. So now instead of rotating this way and traveling our 65 degrees in the positive direction, we're traveling in the opposite direction. And so the way that we can find the measure of that angle is to take our original 65 degrees, imagine we rotated there, but then we're rotating back the other way a full revolution, so we're subtracting 360 degrees. And so if we do that, 65 minus 360, we get 295 degrees. So again, 65 degrees, 425 degrees, negative 295 degrees. These are all examples of coterminal angles. All three of those start at the positive x-axis and one way or another end up at this terminal side here in the middle of the first quadrant. So the easy way to generate any coterminal angle is to either add or subtract 360 degrees to the original angle that you start with. We could add extra revolutions. So here, going back to this one, we rotate 425. We could rotate again or again. So we could keep on adding multiples of 360 degrees to keep ending up on that terminal side. Or we could keep on subtracting 360 degrees and then keep on extending more and more revolutions going this way, and again, still ending up in the same place. So add or subtract 360, and you're going to get a coterminal angle with any initial starting angle. When working with angles that are not between 0 and 90 degrees, so either larger than 90 degrees like the 150 we see here or the 260 degrees here, or angles that are negative in measure like this negative 70 degrees since we're rotating in the clockwise direction. For those types of angles, it's often convenient for us to use a reference angle because many of the features and properties of these larger angles or these negative angles overlap with an acute angle associated with those. And the way we generate a reference angle is to drop a perpendicular to the x-axis from the terminal side. So if we look at this first one here, I'm going to go from the terminal side and I'm going to drop a perpendicular, meaning I'm going to make a right angle here. And so then this angle that's in here, we call it theta prime, or the reference angle that's associated with this 150 degree angle. And so we can figure out what the measure of that angle is by using our understanding of angles. So if I rotate all the way from the positive x-axis to the negative x-axis, that's 180 degrees. So if this angle right here is going as far as 150, then I know what's left there is 30 degrees. And with a reference angle, I'm not worried about the direction I'm rotating or anything like that. I'm just thinking of it as being an angle inside of a triangle, and so that's why I end up with this 30 degree measure positive for my reference angle. In the second example, I'm going to do the same thing. From the terminal side, I'm going to drop a perpendicular, meaning draw a perpendicular line to the x-axis, and that always has to be to the x-axis in order to generate the reference angle, which is going to be this angle that's in here, again, made between the terminal side and the x-axis. So my reference angle is that one right there. So to figure out what that angle is, I can say, all right, to get to here, I've rotated 180 degrees. So how much more have I rotated to get to this terminal side here? Well, I can take 260 and subtract 180, and we'll end up with 80 degrees. So that means this angle tucked in right in here is 80 degrees in measure. So that's going to be the reference angle. So that means when we study a 260 degree angle, we're going to find that it has a lot of overlap with the features and properties of an 80 degree angle. Over here, it was the relationship between 150 and 30 degrees. For our last example, we can see here we have a negative 70 degree angle. So in this case, if I drop a perpendicular, make my right angle, well, what's the measure of that angle inside of that right triangle I just made? Well, it's exactly the same as this one, negative 70 degrees. It's just that I'm going to report it as being positive. So my reference angle is going to be a positive 70 degrees instead of it being negative as it is drawn for me in the original picture. A reference angle is always a positive acute angle that is made with the terminal side and the x-axis.